Hello, good morning everyone. Welcome to my channel Petroleum Engineering. My name is Devans Gajjar and today I will be giving a lecture on Introduction to Drilling Engineering. Here I will be give you the overview of entire drilling process in a nutshell. However, we will discuss about this topic in detail in the further sessions. But let us now try to get acquainted with what actually drilling engineering is and what process are followed in the drilling engineering. So first of all, what is drilling engineering? So drilling engineering is a branch of knowledge where the design in the sense how we will reach from the surface to the subsurface target analysis means the pore pressure prediction, fracture pressure prediction, at exactly at what depth we need to set the casing, we need to set the drill pipe, what type of casing policies we need to determine. Then implement the procedure means whether we need to do open hole logging, in open hole logging, which types of logs need to be performed, then at exactly at what depth we need to perform the cementing operation. Is there a requirement for squeeze cementing? Then evaluation of the cement bonds between the casing as well as the formation are completed to drill a well as sustainably as possible. So, what is the importance of drilling engineering? Drilling engineering is important because till date there is no technology available on this world to extract hydrocarbon without drilling a hole. Since the hydrocarbons are found at a depth about 800 feet to about 3 kilometers, even 10 kilometers, then it is not suitable to do a mining and extract the hydrocarbon. Moreover, the crudes are also very viscous, so they do not have the sufficient energy to flow through it to the surface. However, some natural crude sweeps exist that rely that the crude has came from subsurface to the surface by itself. If the petroleum industry falls down, whole civilization will probably collapse. This is because everything you see all around your day-to-day life is made up of either petroleum or crude product. The vehicle, the wood, carbon, etc. you use are made up of carbon products. Therefore, the survival of our existence, we need to know and keep updating our knowledge, especially on the technology of drilling engineering. Since drilling engineering is a very wide concept, and now the conventional reservoirs have been come to an saturation level, and now the coal bed, etc. So new technologies are needed to be adapted to extract the hydrocarbon from such unconventional hydrocarbon energy reserves commercially. We can extract hydrocarbon uncommercial also, but the unconventional reservoir should prove that the hydrocarbon or a gas which we can extract from the subsurface must be proved to be commercial reservoir. Suppose we input 2 crores, but the refund should be more than 3 crores, 4 crores like that. It should not be less than that. So, based on the motivation human necessities, drilling of hole by excavation on Earth has motivated researchers to develop different sophisticated technologies for drilling engineering. In a word, we can say that drilling engineering has a vital role in our daily life, economics, society, and even national and international politics. As you may be aware that the geopolitics or the crude oil prices defined by the international consumption, let it the WTI crude or a Brent crude, etc. So the pricing of crude oil has an international market. So it governs the economy of the country. Then we will summarize what is the role of drilling during the field development plan. So first we have performed the geological and the geophysical analysis. In geological analysis, the geologists go to the surface, examine the surface structure, take the traverse of the contour, prepare contour map, prepare the sand effective thickness map, etc. And then geophysical analysis. The geophysical is basically the gravity survey, magnetic survey, seismic survey, etc. Sorry, which help us to get acquainted at exactly at what depth we should drill and exactly where to drill. Then combining the geophysical analysis with a seismic survey, we need to get exactly idea about the different types of stratigraphic layers, the structural traps, at which direction the fault is propagating, whether it is a reverse fault, strike safe fall, or a thrust fall. Then, on the basis of this above two data, we drill an exploration well. The exploration is well without having the geological and geophysical knowledge only. It does not have the detailed knowledge since it is the first wells drilled in the prospect area. Then drill the appraisal well to find the boundary or the extent of the reservoir. Then after drilling an exploration well, the mud logging is performed. The lithological texture and the description of the formation from drill cutting and a hydrocarbon show. The mud logging means as we drill the well, the cuttings come up from the surface. And if the cuttings are of very small size, it indicates that it is a hard formation. If the cuttings are of cheap size and it is a very big type of cutting, so it indicates that we have encountered a soft formation. It also tells us about the formation from the drill cutting and hydrocarbon show. If the gas is present, then we will encounter a kick. With the sudden standby pressure on will be increased. Then coring. Coring is performed to give the actual sample from the formation using the sidewall coring, percussion coring, etc. So on the PVT lab, we find the porosity, permeability, capillary pressure, wettability, interfacial tension, etc. Various other petrophysical properties of the rock. Well logging. Well logging is electrical logging. In from electrical logging, we can get idea about the resistivity of the formation, the water saturation of the formation, whether the formation is having permeable or not. From radioactive, we basically get an idea whether the formation is shale, sand, or shaly sand. From sonic tool provides a quantitative assessment of the fluid type. From sonic tool is used to identify whether the gas is present or whether the fluid is present in the distribution. Well testing. The following the wells allow the large representation samples of the reservoir fluids to be recovered. The well testing is used to examine the fluid samples from the reservoir. It is also used to determine the pressure response from the build-up test, drawdown test, etc. It allows to show the extent of the reservoir producibility and the drive mechanisms can be evaluated. If the pressure of the well is not decreasing, we can say that it is a strong aquifer support. If the pressure is decreasing suddenly, and if the hard drawdown is applicable in a gas cap reservoir, then there is a chance that the gas cooling might occur in the reservoir. Then evaluated information is gathered, collected from exploration, appraisal, well information, compile a geological model. Then we develop the economic model, means exactly at how many wells we need to drill in a prospect, what will be the total cost of drilling the well, and what types of estimated reserves can be proved to be commercially viable. Then we drill the development well. So on this process, we will discuss in detail in the further class. Till now, just understand what is need to say. So if you wish, you can draw this flowchart in your text. It will be helpful for you. Now, the sequences of drilling operation. It is categorized into three steps. First is the drill the hole. Second, the casing operation. And third is the completion operation. However, a well is drilled in a high pressure zone, weak and a fracture formation, unconsolidated formation means the formation is not very consolidated, it means a loose sand like thing, sloughing shells. The shells are very fissile, they break easily. So they must be completed without any excuse towards substantial destruction at the reef side. So in the different isolation zones, we need to put the casing depending on the formation strength. The formation at the casing is the weakest formation. Since at the casing sheet, the formation will be fractured very easily. Then how drilling a hole. First, we drill a hole of a large diameter, and gradually we decrease the size of the hole. This is because the same, if we keep the same diameter of the hole throughout from the surface to subsurface, then the hole might not be stable. It may collapse in between. And also it took more amount of economics, more time, and also more weight of the drill pipe. So depending on the formation, we try to drill the hole with a different diameter. First hole is drilled above 36 inch where 30-inch conductor casing is placed. Then we drill a hole of 27 5 by 18 where the 23 3/4 of the conductor casing is less than, and gradually we taper the hole to reach from the surface to the subsurface. Then what are the functions of casing? The casing pipes are put into the valve for the following reason. It isolates the troublesome and unstable formation, which includes heaving shell, loss circulation, and flowing halite. Here, halite is basically the salt dome. In a salt dome, the salt is very low. As soon as we drill the through the salt dome, the salt comes in contact with the water. It dissolves, and the rapid collapse of the salt dome occurs. So, to isolate it, we must put the casing. To isolate the different pressure of the fluid region such as gas zone to protect the freshwater zone. Since it is very much essential that if we drill that the pump pressure is increased in order to remove the cuttings from the subsurface to the surface. So with respect to depth, the hydrostatic pressure increase as a result of which the the fluid migration laterally across the freshwater zone increases. So first we need to put the conductor casing in order to isolate the freshwater zone so that it cannot contaminate it. To protect the producing formation from mud and mud filtrate contamination. It protects the producing formation from the mud and the mud filtrate. The drilling mud is used, and as the drilling mud passes through the well bore, the drilling mud cake is formed around the sides of the well bore, and the mud filtrate is passing through the formation due to the porous and the permeable nature of the formation. To protect the weak zone from the breakdown caused by heavy mud, whose hydrostatic head is required for pressure control purpose and the lower section. The control well pressure by contamination of downhole pressure. The means we need to control the well pressure by controlling the downhole pressure. Means we have to provide an adequate amount of hydrostatic head so that the kick or a blowout cannot occur. To provide a stable seat for packers, liner hangers, etc. The casing is used to provide a seat. Means there is a seating mechanism at the near the casing, so where we can hang the liners and as well as place the packers in the production casing. To support the wellhead and the BOP stack. The casing is used to support a wellhead. Note that a wellhead is used in case of production and the BOP stack is used during the case of drilling. BOP is basically blowout preventer. It is used to prevent the uncontrolled flow of formation fluids from the wellbore to the surface. To confine produced fluid to the wellbore and provides a flow path for it. So these are the casing program. First, as you can see, we have drilled a 36-inch hole and the outermost casing we have placed the dark black color one, which is a 30-inch casing conductor pipe. Then we have drilled another hole and where we have placed a 20-inch surface casing. Then again we have placed a 13 3/8 casing, so which is of intermediate casing. Then we have a 12 quarter 12 1/4 as a casing, so which is liner, and the 9 5/8 is our production casing. So our casing size varies from 30-inch conductor casing to 9 5/8 production casing. In between we have a surface casing of 20-inch, intermediate casing of 13 3/8 line. So we have followed here the three casing coils. As you can see, the conductor casing, surface casing, intermediate casing, and the production casing. Conductor casing is not considered as a casing exactly. It is considered as a conductor pipe of a very large diameter. Estimation of pore pressure. In a wildcat well, pore pressure prediction is done by analyzing the seismic data. Means the pore pressure is estimated from the basis of from the depth of the formation. Generally, the pore pressure gradient is considered as 0.43 psi per feet, just as of water. So, with respect to depth, we need to multiply pore pressure gradient multiply by depth. So, seismic data is required by creating acoustic waves using explosives. Where the explosives used are dynamites, gongs, vibrosis in desert areas, and the wave traveling type is measured down the subsurface, reflecting back and then to the surface. As these waves are generated on the surface, they are sent to the subsurface, where these waves are reflected and are received at the receiver with the help of receivers, which are called as the geophones in the land or hydrophones in water. The point of origin of the waves on a surface is called as a short point, and the returning waves are detected by the series of geophones or hydrophones as discussed. Hydrophones are used in offshore, geophones are used in land survey, and known distance from the velocity at which the seismic or acoustic wave is propagated to the formation depends on density and elasticity of the rock. If the formation is higher density, then the wave will be reflected easily. Imagine that you have a very hard iron bar, and if you pass the sound will be very easily travel to the next end. And imagine you have the thermocol or thermocol sheet, so that the sound will be not traveling very fast. Means its density is very light compared to iron. So the density plays a very important role. The overpressure cells are undercompacted that result in lower density and elasticity. Since overpressure cells are not compacted, the cells are very fickle, they are very brittle, they break very easily, and they are not very strong because they are under compacted. So it has a very less density and less elasticity with compared to sandstone, limestone, dolomite, or other types of formation. It is necessary as it helps us to determine the amount of mud weight during the drilling operation. The pore pressure helps us to determine how much amount of mud weight we need to keep, whether 8 ppg mud, 10 ppg mud during the drilling operation. It helps us to identify abnormal pressure zones. Then the second is introduction to casing design. The following criteria must be considered during the casing design. Burst. Now what is burst? It is the pipe failure that occurs when the pressure inside a pipe is greater than the internal real value. When the inside pipe pressure is greater than the maximum allowable pressure of the pipe. Means exceeding that pressure, the pipe will burst. Means it will fluid will flow from inside to outside of the pipe, causing the pipe to crack. Collapse pressure. The collapse will occur when the external force on the pipe is greater than the combination of internal pressure plus collapse rating of the pipe. So the collapse is basically the outward stress of the pipe. Means the stress is applied from the outward, which is greater than the internal pipe pressure plus as well as the yield strength of the pipe. If the external pressure is greater than the internal pressure of the pipe plus the strength of the steel pipe, then the pipe will collapse from outside. It occurs as a result of either combination of reduction in hydrostatic head exerted by the fluid inside the pipe. So as the hydrostatic head decreases, the pressure from the formation to drill pipe increases. So it can chances that a drill pipe might collapse. So increase in hydrostatic head exerted by the fluid outside the pipe. Since we have the very high hydrostatic pressure outside the drill pipe. And suppose if we are having the barriers outside the drill pipe, like a scaving scale, sloughing shell, etc., that is the clay has swelled and the drill pipe has suction. If we are continuously pumping it, then the pressure from outside increases, which causes our pipe to collapse. The mechanical force created by plastic deformation, flowing salts, etc. As the salt flows, it erodes the tubing, so its plastic formations can occur. Tension. It can occur when the pull exerted on the pipe is great for the tensile strength of the pipe or a coupling. The above three factors result from the following situation. Inadequate fill up of the casing when the casing is not properly filled with the drilling mud in order to maintain the hydrostatic head. Loss circulation means suppose we have the formation having the sudden valve collapse with permeability and porosity is very high, so the loss circulation occurs. Then the cementing. Using the cementing, we need to squeeze the cement at a very high pump pressure in order to push the cement from the conductor casing to the sidewalls of the annulus. Then the casing were due to small size of sand particles, etc. Air or foam drill in the casing is designed for evacuation plus allowance of air due to loss of lubrication. Since we are using air and a foam as the drilling fluid, especially in the Saudi or Arab countries. There is a wear loss due to lubrication that the casings will not get any lubricant like oil types, etc. So the casing walls will be becoming rough, and over a period of pumping time, its internal diameter will get increased and the thickness gets reduced. Highlight section is basically the salt section. Hydrodon for testing purposes is generally expected in exploratory well. It will not be subjected to hydrodon, but it should be considered for development wells. Acidizing or fracturing the horizon result in increase in external loading to depth above the packer if the path of communication exists. Means if we fracture the formation, then we need to pump the fluid at a very high pressure. So if external loading at a depth above the packer will exist. So similarly, the squeeze cemented increase the external loading since the pump pressure increase and we need to squeeze the pump as there is already some cement present in the annulus between the casing and the formation. So we need to squeeze it. So as a result, we need to apply more force and the more internal pressure and there are the chances of collapse robust might occur. The corrosion will eventually decrease the collapse strength of the pipe. As the sands or fines are encountered in the casing, they will erode the casing over a period of time. And as a result, the thickness of the casing is reduced. Its internal strength or collapse strength is also decreased. Here in this figure shows the example of the valve which has been drilled and the valve head has been installed and from this pipe the production of the crude has been taking place. After completing the casing design, we have information to select the wellhead. So as soon as we complete the casing design, then we need to select the wellhead design that exactly after drilling operation, how much size of wellhead we need to select. The wellhead must be of a correct pressure rating. It is designed for service like H2S and capable of accommodating all design and contingent skill. In wellhead, all the types of casings will be attached to the wellhead from the surface casing to the production casing. Here, conductor casings are not attached to the wellhead because in a conductor casing is basically the cellar. If the cellar is above the ground, we need to go for conductor casing. If the cellar is below the ground, we do not need to go for conductor casing. What is cellar? The cellar is basically the space between the drill floor, the rig floor, and the surface. Now this is a picture of blowout preventer, which has the annular BOP, shear ram BOP, pipe ram BOP, glide ram, different types of pressure ratings BOP that we will discuss in detail in further lectures. Now let us just understand BOP's requirement for a well will depends on company policy and anticipated bottom hole pressure. Means suppose the gas kick has occurred and it has a pressure of 5000 psi, then the BOP must withstand that pressure suddenly and it must have the pressure ratings greater than 5000 psi, that is about 8000, 9000, etc. The surface also has a no BOP requirement. While surface hole basically means a conductor casing. The conductor casing do not have the BOP as where to install the BOP because since no casing is installed, so we need to use a diverter. The diverter will not prevent the blowout, but it will divert the incoming flow of fluid from the formation uh, to the surface. Then this is an overview of the cementing program. Cementing is used for the zonal isolation of the well. The effectiveness of zonal isolation depends on three main factors which is considered at the planning stage: slurry design, casing selection, displacement methods. Slurry design is basically we need to use retarders, extenders, how much, what class of cement we need to use, compensators we need to use, and casing accessory selector with top slug, float slug, etc. Then displacement methods means either we need to go primary displacement, secondary displacement, or tertiary displacement. Then the slurry design. The cement slurry consists of water, cement, and additive. The first is the calculation is to calculate cement volume. Second, we calculate the bottom hole temperature. The first is to calculate how much volume of cement will be required. Then second, we need to calculate bottom hole temperature. Since bottom hole temperature is important because if the temperature is very high, the water content will be evaporated from the cement and the cement will harden easily. So the temperature of bottom hole is very important. The third, we consider the type of drilling mud, whether it is oil based or a water based. Some basic definition: yield of the cement. Then is the cubic meter per sec. Is the volume of a space the slurry will occupy after mixed with the water and additives as per design specification. So it is basically the volume that will be occupied by the cement after it is mixed with the water and other additives. As if the yield point is high, it will contain a large amount of water and therefore it has a low density. If the yield of the slurry is high, it means that it has a more water content. So as the density of additives and cement is greater than water, and but if it has more water content, it has a low density. Density is an important factor since the slurry must be dense enough to control the formation pressure. Means while pumping the cement, the density of the slurry must be greater than the hydrostatic or formation pressure, but it should not cause the formation burden, but because it should not cause the fracture of the formation. Lightweight slurries are produced by adding extenders such as bentonites to the slurry mixed with water by aerating the slurry. Bentonite is used to increase the thickening time of the cement. Extenders are nothing but basically is used to increase the thickening type of cement. Wetting materials such as ilmenite, hematite, barytes are added to increase the slurry density. Thickening time determines how the slurry remains pumpable. It depends mainly on cement composition and downhole temperature. As we have said, if downhole temperature is very high, the water will be evaporated, the slurry will not be remain pumpable, the pump pressure will increase, and the hardening of cement will be very fast. It is manipulated by using the retarder. The retarders are basically used to decrease the setting time of the cement. Third is mixed water. The amount of mixed water usually depends on the slurry density. The water type used is usually which is most readily available, that is the sea water in offshore and the fresh water in onshore well. If the casing is cemented across salt or a halide section, the mixed water should be salt saturated to prevent anionic exchange between the slurry and the formation. The compressor strength. The cement has the compressor strength to support the casing and isolate the zone. And as the cement is placed between the casing and the formation, it must have the sufficient strength that it should not be gets eroded or collapse, or there not be any formation of channels between the casing and the formation. So the complete isolation of the zones should be there. If it is a great deal on the downhole temperature, if the temperature is too low, it allows particular slurry to reach the compressor strength for reasonable amount of time. So as we have discussed that if the temperature is too low, then the amount of time that a slurry requires to harden will be very more. So to accelerate that, we had accelerators such as calcium chloride to decrease the thickening time of the cement. The fluid loss. This is the amount of water lost from the slurry to the formation for a given pressure difference. Means how much amount of water is lost from the slurry to the formation if we apply the given pressure difference, will consider as a 1 psi. To combat this problem, chemicals are used for slurry jobs which entail high pressure difference between slurry hydrostatic pressure and formation pressure. Flow characteristic. Fluid flow characteristics contribute to good formation bonding and less pumping difficulty. If the cement is flow very easily, then there will are less chances that channels or a void space are developed behind the casing and the formation annulus, and we have the less pumping difficulties because if some channels are left in the cementing job, then we need to do the squeeze cementing, which means needs to pump the cement at a very high pressure from the casing into the format annulus between the casing and the formation. As a result, there are the chances that that non-productive time of the drilling is increased, etc. Additives are available to reduce the cement friction and encourage slurry turbulence at a low pump rate. Then casing accessory selection. A casing screw is screwed or welded onto the lower end of the joint. So now it serves as an aim to guide the casing in the open hole and has a hole in the middle which allows the mud to pass freely through the casing string. Here the guide screw is not widely used. The float screw is similar to guide screw, but it contains the non-return wire that it allows the fluid to flow from top to bottom, but it does not allow the fluid to flow from annulus into the casing. As a result of it gives us the better well control during running of casing, and it should be filled from the surface during the casing runs. Differential fill of screw. It uses a valve that allows the mud to flow into the casing from the bottom to keep it partially full. The steel ball is dropped and pumped into the screw to shear out the seat and convert the screw to the regular float type. Here the mud is flowed into the casing from the bottom to keep it partially full. Means the casing is not completely empty, but some amount of mud is filled into the casing and the steel ball is dropped and pumped the shoe. Means after putting the steel ball, we have pump into the slow and we as the pump pressure increases, the wall shoe sheet shears and convert the shoe to regular float type. Automatic fill shoe. It is designed to avoid having a fill up of the casing one time from the surface. It incorporates wedges to hold the check valve open. Since this has a wedges to hold to keep the check valve open so that the mud can flow both in and out of the casing wisely when required. Automatic fill shoe can be tripped to act like a regular flow shoe by pumping down the string at a preset rate to the pump the wedges out. Float collars are usually placed at a one or a two joints. See, this is the one joint of the casing, and here the float collar is placed. It is one joint placed above the float collar casing. So they have served as a top for cement wiper plug. The float collars are used to wipe the cement that is residing on the walls of the casing and is not displaced into the air. The float collar provides the backup for the float. So the wiper collar is normally a the casing covering which a wiper plug is designed and sealed to allow the pressure testing of the casing. Highly debated wells. How about a debated well? The debated wells are wells whose inclination is greater than 60 degrees. Means they are not exactly vertical. The benefit of drilling debated wells is to increase the length of the completion zone when we get more exposure to the reservoir area and the effect of gravitational force increases as the angle of inclination increases. As the angle of hole increases, axial component of gravitational force reduces whereas the lateral component increases. In diameter when there is a high friction resistance, since when the pipe is bent, there will be more friction. Since there is no uniform annulus between the drill pipe as well as the formation. The one side of the pipe will always be in contact with the formation. The tendency of the solid to settle from the drilling fluid and cement lesion in deviated wells, the gravity component will play a very important role. Then there are the chances that if the solids present in the drilling fluid will get settled at the bottom, and it becomes difficult to drive further, which gives a chance to the differences sticking. Second, third, it becomes it's more difficult to control the direction and apply weight on bit. Since some amount of the gravitational force component is reduced, then we cannot apply the sufficient weight on bit, and also we require some advanced methods such as geosteering tools to control the direction of the well. And what is mud program? The determination of a mud width requirement is to maintain primary well control. So the main function of the mud is to maintain the hydrostatic pressure. Second, the determination of a trip margin. That is when the drill pipe is pulled out wet or dry, which we will discuss in further. Then adequate amount of mud must be kept ready to be filled in the hole, which provides the primary well control to give program mud weight. Trip margin means as the pull out the drill string, the amount of volume of the pipe that is pulled out must be replaced with the volume of the mud. so that the hydrostatic pressure is maintained. The mud bed must not exceed the formation or fracture. If it exceeds the formation strength, it will fracture the formation as well as we lost the drilling fluid and the where our mud pit level will get decreased if we fracture the formation and a loss circulation will start. Analysis of formation to be drilled and like reaction to this available drilling fluid organism. There are four types of mud: water-based mud, freshwater mud, seawater mud, calcium mud, lignosulfonate mud. These are classified based on the amount of additives added to that. And a polymer mud, we use guar gum, linear gel, synthetic cross-link gel, etc. Oil-based mud is basically an invert oil emulsion, environmentally sensitive oil-based mud, and a true oil-based mud. Then we use fluid loss requirements. Means the fluid should not be lost very frequently. Means mud cake should be formed very easily, and so as to prevent the fluid loss into the formation. And determination of pH. If the pH is very low, it will contaminate the formation. Viscosity. If the viscosity is very high, then our pump pressure will increase, and it become difficult to circulate the drilling fluid out. The analysis of the rig mud treatment made the whole requires the selective mud and temperature stability required. In upcoming lectures, we will discuss all the topics will be covered in detail. Please give your feedback in comment section. I will try to help you in the best possible way I can. Thank you, and please subscribe to Petroleum Engineering channel.